Hi, everybody. Very excited to be back here in the second session of the conference. In this session, we're going to talk about lifetime scenarios, which, in my opinion, is a really hot topic right now, because as you probably know, most of the criticism that is out there on the current scenarios on climate change and sustainability are criticizing that those scenarios are heavy on technological change, but very weak on behavioral changes and lifestyle changes, as a matter of fact. So I'm really happy that we're going to break the ice here with this insightful discussion. We have 4 presenters, as well as in the previous session, which are going to be Tariq Omahani, Sibile Brunhat, Inigo Capean Perez, and Vincent Moro. And without any further business, I'm just going to invite Vincent Moro to start his presentation, which is about low emission scenarios for Europe powered by lifestyle changes. And Vincent is from Swiss Federal Institute of Technology. Vincent, the mic is yours. Thank you.
Thank you, Ailosha. Good morning, everyone. I hope you hear me well and see my screen.
Yeah, yes, we do, Vincent. Perfect.
And it's really this question of trade-off between technology, so technical solutions, which we could simplify as efficiency, and not technical ones, which we might say is sufficiency. And so how do they compare? And just to give you an example is we look at improvement on the agricultural practices, on the supply chain of food, or on the transport supply chain versus changes in diets, for example, or changes in transportation patterns, shorter distance traveled, higher occupancy rates, and so on. The main motivation was really that the European High Panel on Climate Change said that lifestyles were a complement, at least, to technological solutions. And we asked a few more specific questions, such as if there are complements, can they also be substitutes to technological changes? For example, we're also interested in looking at how much lifestyles can reduce emissions and at what economic costs, always compared to technological changes. And can lifestyle also steer technological changes away or closer to some higher or lower tech options, or higher and lower cost options, to reduce pressure on resources in society. One of the also an additional question is which we've been talking about in this conference quite a bit already, is can lifestyle changes question or at least challenge some of the imperatives in energy modeling, such as carbon removal technologies, so CCS and BECCS. Just to talk briefly about the model that we use, the European calculator. It's a relatively broad and complex model that covers 29 countries, so the EU 27 now, plus the UK and Switzerland. It runs from 2020 till 2050. And it was a large effort from a consortium of European research institutes. And what we'll focus on mostly today is this lifestyle module, that essentially sets the demand for products, activities, and so on. The modeling process itself started with stakeholder consultation. Some of you might have been at the lifestyle module consultation about 4 years ago now, 3 years ago. Essentially to validate or to challenge some of the hypotheses that we used in building a lifestyle module, which represents some of the key behaviors related to energy, which was then integrated into a full scale model covering the 29 countries and a range of sectors. The main outcome of the European calculator is what we call a transition pathway explorer, which you can all access easily online. I'm going to try and move my picture so you can see. Maybe I can't do this. But anyways, it's available online at tool.european-calculator.eu, and you can play with many different scenarios. Some of the main characteristics of the model is that it's a simulation model instead of an optimization one, in the sense that we can impose some behavioral changes without necessarily waiting for some incentives or policies to change behaviors, and that allows us to test a number of behavioral changes. So it covers the EU 27 plus 2 UK and Switzerland, as I said, the rest of the world through GTAP. And then the main characteristics that interest us here is that it works with levers and different ambition levels. And so these different levels are from 1 to 4 historical trends. Say in transportation, this would be like having zero emission vehicles represent a small share of new sales in 2050, all the way up to transformational, where we would expect that by 2050, 100% new sales of vehicles might be zero emission, either battery or fuel cell vehicles. And two scenarios, two levels of ambitions in between. The range of sectors that can be modified is quite high. I haven't expanded everything here, but you can see that there are sectors that relate to population dynamics, of course, urbanization, as well as the main constraint, which is the global mitigation effort. And also a range of behavioral changes related to travel, to housing, diets, and general consumption. And some of them overlap, some of them might be in technology and fuels, as we'll see in some of the results. We tested 3 scenarios. One which is a lifestyle change scenario where we essentially go on the highest ambition for some of the lifestyle changes. Nuclear is phased out. There's no CCS, no carbon capture and storage. The only carbon removal technology that is used here is essentially land left fallow and that regrows into forests. Renewable energy deployment is essentially driven by demand and sort of capped so that as a function of storage capacity, agricultural systems move towards agroecology standards, and population and urbanization and trade is kept as the EU reference scenarios, which is roughly equivalent to the shared socioeconomic pathways. So that's the first scenario. The second scenario is to go all out on the technology and fuel changes, which means that nuclear remains a significant part of the electricity mix, that we deployed carbon removal technologies, and that essentially agricultural system further intensified. And then the main part, and where we like to show some of the trade-offs between the two, is to combine changes in lifestyles and fuel and compare what the results might be. It's not exactly going all out on both lifestyles and technology, because, of course, if you reduce some of the demand for energy, you don't need to deploy so much of the technology. And so there's some sort of trade-offs that are present already in setting up some of the scenarios. Agricultural practices in this case are set to the EU REF scenario. So some of the results now. We kept green for lifestyle changes and blue for technology throughout the results, so you can identify them relatively easily. What we show here is that if we go all out on lifestyles, there's about a 65% reduction in emissions compared to 1990 level. Whereas if we go all out on technology and fuel, there's about an 80% reduction in emissions from 1990 level. So the first main result is that none of the changes can bring us to net zero by 2050 by themselves. So we need both, obviously. But the important bit is like how much lifestyles can really bring is quite substantial compared to technology and fuel, so efficiency changes. So that's overall. If we move now to different sectors, and here I've identified 5 of them, large ones: agriculture, buildings, electricity, industry, and transport. We can see that on the differences between the two, clearly lifestyles changes bring significant reductions in agriculture, and we'll detail this as well. In buildings, maybe unexpectedly a bit less. Some of the changes that, or perhaps the lifestyle changes in buildings is low, especially because climate feedbacks, as we've seen, decrease quite a bit emissions from the building sector. And this is what we expect to continue. Also, some of the use of appliances in buildings and related to lifestyle changes, fewer appliances, longer lifetimes, and so on, are found in electricity rather than buildings themselves. And so in electricity, we see that changes in lifestyles and changes in technology are very much comparable. In industry as well, and transport, lifestyles bring a bit less, but we'll detail this together with agriculture now. So if we look at the transport sector, we know this is one of the few sectors where emissions have been rising instead of decreasing in the last decades. And what we can immediately see is for passenger transport, the contribution of lifestyles here in green is almost equivalent as the contribution of technology changes. There's a difference of about 80 million tons for Europe as a whole. So it's rather small. And that's just from essentially from higher occupancy rates and from shorter travel distances. In terms of freight, lifestyle changes, essentially demand for products and services, still contributes about 50% of what we could achieve with technology. So that's a difference compared to 2015. The important thing now is that we also looked at sort of second order effects. And so if we reduced this much
Okay, it appears that we have some technical issues. Just give us 1 minute, we'll try to resolve that, otherwise we'll rearrange the speakers and I get back to you in 1 minute.
Apologies, I think my connection went out. I hope you can still hear me.
We hear you sounding clear. You just continue your presentation.
Thank you. So I'll move a bit quickly back to some of the results in the transport sector. And what we have also looked at is how electricity demand would change over time. And clearly, towards the electrification of transportation, we expected technology changes to have a strong impact on the demand for electricity, which we can see here with the blue curve. The dash curve is the EU reference scenario, and the lifestyle curve starts more or less the same, then diverges and stabilizes in 2040. So clearly, this is the result of shorter distance travel and essentially higher occupancy rates in vehicles. In terms of investments, we distinguished, with respect to the EU reference scenario again, we distinguished between investment in infrastructures and investment from households. And just to give you an example, investment from households in technology and fuels for transportation is essentially buying a new car, whereas in terms of infrastructure, it's installing chargers, for example, or fuel stations for hydrogen and so on. What we can see is that in terms of households, the difference in investment will be small, whether it's a lifestyle change or a technology change, switching vehicle or bringing more people in one's personal car. Whereas on the infrastructure side, there's clearly a lower investment cost at first for lifestyle changes, and then it hovers around with not much difference from the EU reference scenario. So that's a positive side in terms of how much can be achieved through lifestyle changes compared to technology and changes in technology and fuels. Let's look at agriculture as well, because that's a big one. Okay, 5 minutes. What we try to model is not so much going all vegan and so on, but essentially following or modeling the recommendation of the WHS, the WHO, the World Health Organization, which it still includes some meat, a lot less than we eat today, but about 90 grams of meat a day. And what we can see is that even such small changes bring a lot of difference in terms of emission. Food waste also brings a difference, and this is going beyond some of the SDGs, which recommend about 50% reduction in food waste by 2030. Here we go to 75% reduction in food waste, and that's on the consumer side. And they obviously bring a much larger reduction in emissions compared to the intensification of agriculture. The yellow line at the top is again the EU reference scenario. If we look at the distribution of potential reduction in diets across Europe, we can see that some of the big meat eaters have clearly more potential reductions than others. Now, to bring us to a conclusion, the important part of it was to combine the results of lifestyle changes and technology changes. And what we can see here is if we essentially that in proportion lifestyle changes are relatively small, but they remain very critical in the sense that they could avoid deploying some carbon removal technologies to achieve net zero by 2050. And so this is really critical in the sense that they are essential complements and substitute in some cases as well to technology and fuels. Essentially because they can compensate carbon removal technology, they can also compensate some of the land use removal changes in land use that remove carbon from the atmosphere. So just to conclude, clearly the contribution of lifestyle changes is critical and can bring a lot of reduction, in particular in agriculture, so switching, changing diets and reducing food waste, for example, where technology is nowhere near in terms of greenhouse gas reduction. There's also many co-benefits to lifestyle changes, which might be far-reaching, and as we tried to show, at least with the demand for some mineral or metal resources. So clearly some benefits there, and we don't even account for the emission reductions related to the reduction in the extraction of some of the metals. So that would be some additional benefits as well. There's also some sort of compounding effects in the sense that without lifestyle changes, technology would have to pick up some of otherwise some of the land use changes would have absorbed because of lifestyle changes. So clearly these sort of compounding effects are important when we look at lifestyle changes. And then maybe to finish up, there's an important part of lifestyle is that they're immediate. They bring the benefits now, as we might see with emissions in 2020 due to COVID-19. So essentially, the longer we wait, the greater the potential contribution of lifestyles will be. And I'll end it there and look forward to some of your questions.
Thank you very much, Vincent. Unfortunately, we have only about 3 minutes, so I'll just pick 3 questions and maybe 2 or 3 questions, and I will ask you to be succinct as much as possible. The first question by Anneli would be, how much do the reduction in passenger transport come from changes in daily travel, like commutes, versus less frequent long-distance travel, such as annual vacations in Maldives?
So good question. There's I don't have all the numbers at hand. But we could perhaps move that question to the discussion to Discord afterwards, and then provide detailed numbers as well.
Perfect. Okay, then another question would be, what's in your opinion the impact of indirect emissions on the scenarios? Isn't it that some things that seem most efficient now might actually cause significant indirect emissions that might then dilute the improvements?
So by indirect emission, I'm assuming it would be sort of embodied emissions in trade, for example, or in all the emissions related to trade are accounted for, and clearly in some of the technology changes, we do require more materials, and so the emissions, as you could see for the transport sector, the emissions related to the extraction, for example, of metals and their imports would be quite high. Whereas if we simply increase the occupancy rate in passenger vehicles, these emissions are already forgone.
Okay, maybe a very brief one on the link between policies and lifestyle technology. So you talk about some hypothetical scenarios, how we might get close to net neutrality by 2050. But what are the actual policies? What is the link between what you present and the policies that would take us there?
So the nice thing about this model is that we can really test scenarios before any policy comes is implemented, and I would say there's the good thing is that changes are not, even on the highest level of ambitions, changes are not so far-fetched. And so policies to encourage such changes on the lifestyle side, at least, would a priori be easy to implement. We haven't looked at detailed policies and how they impact the different scenarios, but at least they seem reasonable.
Thank you so much for this insightful presentation, Vincent. I do encourage you to continue interacting with the audience. I see you got a lot of questions in the Discord after the session. And now we're going to move on to Tadiko Mahani from Finland Future Research Center, who's going to talk also about the sustainable scenarios in the EU, however, from the more of a post-growth perspective, if I'm not mistaken. Your mic is
good morning,
Tariq.
Good morning, everybody. Thanks so much, Aljosa. I hope you can hear me okay, because we've been having some technical difficulties on this side with the signal as well. To give you a little... Great. To give you some background on this research project, it began as a Marie Skłodowska-Curie action, an individual fellowship, in 2015, funded until 2017. I suppose there was two major parts to the research. One was actually looking at different ideas of well-being, or what sustainable well-being might be, and the second is how you could model that. So originally it had a focus more on energy modeling, and there was, I suppose, early in 2015 and into 2016, there was a kind of an acknowledgement within the research that a more interesting question was actually to look at consumption in terms of its relationship with well-being, and what the kind of emissions reductions you could get in lifestyle scenarios or sustainable well-being scenarios that considered consumption rather than just energy. So I suppose I expanded a lot on the kind of theories and concepts around well-being, and then was also expanding around the modelling. So I suppose that has also had, I suppose, the consequence of this research is not complete yet. It's a work in progress. I'm now back to it full time after doing some work for the government here in Ireland and some consultancy work. I'm back to it full time now to complete it. So to kind of characterize, I suppose, from that, what is the problem? I think Celine kind of elegantly put it earlier when she was describing the kind of challenges that we have in terms of the long-term emission pathways. This is from the fifth assessment report from 2014 to kind of understand just how significant we need to reduce emissions throughout this century. Of course, that has been advanced since in terms of understanding pathways towards 1.5. Celine also mentioned that. It basically means in the wealthier countries, we need to eliminate all greenhouse gas emissions within the next 30 years. We know this is an enormous challenge. We also know that a technological framing solely of that, and Vincent has usefully put it in the last presentation also, just a technological framing which tends to come from quantitative modelling, in particular the kind of dominance of integrated assessment models, pushes us towards considering technological changes and, for example, the issue of biological energy, carbon capture and storage, the BECCS issue that has also come up, and the reliance on that. And there is also a need to consider a more fundamental issue of how we actually look at consumption and its relation with well-being. So we can see kind of here, we know that there's a kind of an exponential growth in terms of material resources, and related to that is our increased emissions. We need that curve to go pretty much exactly in the opposite direction at a similar rate, which is an enormous challenge because you have not only high levels of consumption in the wealthier countries, but it's also growing in the economic elites of developing countries and middle classes. So the IPCC reports have increasingly been acknowledging that we need to look beyond just territorial emissions to look at consumption-based emissions, to get that perspective on high consumerist lifestyles and high consumption lifestyles, which are spreading throughout the world, classified by Mary Douglas in cultural studies as consumerism basically being the cultural identity of the westernized and wealthy societies. So to explore these links between consumption and well-being becomes an increasingly important issue. If you can see here to the right of the slide, you can see both represented. This is from the emissions gap report of late 2019. Both the territorial emissions on the lower line, and on the higher dashed line is the consumption-based emissions. And you can see in terms of also including that import-export trade balance, there are significantly higher emissions if you look at consumption-based. You can also see, interestingly there, while China is the highest emitter, of course, on a consumption-based perspective, it is actually lower because a lot of those emissions are actually exported to Western countries. Consider some kind of answers to these deep challenges methodologically and deep challenges to policy in terms of how can we can lever a more sustainable transformation into the future. Well, framing, I believe, is one of the key issues. In terms of the territorial based emissions not giving us the full perspective. Also, that energy, technology and marginal cost have dominated from a lot of the modelling approaches we've used around optimization and integrated assessment modelling. Sustainable consumption and production have kind of acknowledged that efficiency approaches and also just relying on the individual level of behaviour have proven not sufficient enough, that we also need to consider structural changes. We also have challenges in terms of our kind of philosophical understanding of development globally in terms of economic growth. That well-being is greater than income and consumption, related to that philosophical discourse. Also, that change is complex and systemic, not necessarily deterministic about the deus ex machina of dropping in bioenergy, carbon capture and storage, or indeed renewables and energy efficiency, which are necessary but not sufficient for sustainability transformation. So this requires a reconsideration of the fundamentals of how we understand transformation and transition. And this, in a methodological sense, must encompass wider scenario approaches than just relying on models. And this has a tradition not only in the field specifically of future studies, but also in mitigation and transition. This has been acknowledged since the special report on emission scenarios in 2000 by the Intergovernmental Panel on Climate Change. So in terms of considering some of the aspects of how we actually break the link between whether you articulate it as consumption as an economic phenomena, or consumption as a material phenomena, which is also related, strongly related to our levels of income. We can think about Tim Jackson's idea of the double dividend is a very interesting idea that many people will be familiar from. Aljosa mentioned that part of this research relates to post-growth and degrowth, and that's very true. Jackson's idea of the double dividend that he has been pursuing with his group in the Center for the Understanding of Sustainable Prosperity for some years is that potentially it's possible to increase overall levels of well-being while you're reducing consumption. But that involves really, I suppose, articulating also what well-being actually is, because a lot of how we've understood mitigation and transition in recent decades has been around energy decarbonization, chiefly energy efficiency and zero carbon energies, particularly renewable energies, but also nuclear. And that framing, again, is necessary but not sufficient. We need to also think about dematerialization, how we dematerialize our economy to actually consume less resources in terms of production systems. But immaterialization is an even more fundamental philosophic proposition, that we need to think about well-being, happiness, and sustainability together. And how it's possible maybe that well-being is not just linked to the consumerist idea of in cultural studies, that's how we derive our well-being, that there are wider ideas, and that there are now emerging priorities to consider these not just separately, but now together. In the Maxwell project, the Maxwell means maximizing well-being and minimizing emissions. The concepts and theories are relevant to human well-being. Well-being broadly conceived, where there are scenarios for future human well-being in the EU to 2050. Different well-being pathways can combine kind of the micro or individual level in terms of agency, in terms of what makes our own free conceptions of what a good life could be, but also sustainable development pathways at the macro level. What kind of institutions, governance arrangements, technologies, and other macro elements, including relationships with Mother Nature or the natural world, and the importance of ecocentrism, how they can actually flesh out what a well-being pathway might be. And this is then varied through the level and structure of consumption in the Exio-based model. Originally, the plan was to use the WIOD model. I've moved to Exio-based, helped by my colleague Arcaiz Usubiaga-Liano from University College London, who's helped me who has actually coded this model kindly. And it's actually, it's in some ways, a similar to approach by Gibran Vita, who I think is already in on our group, who's done some really interesting work on looking at needs-based perspectives brought into Exio-based. But the overall approach in Maxwell is that looking at well-being and then seeing how we can immaterialize and dematerialize well-being to establish GHG emissions levels in the EU to 2050, rather than just relying on technological scenarios. So to give a brief idea of what we mean in terms of sustainable well-being, There have been various reviews from various different fields across anthropology, cultural studies, psychology, capability, needs, around the different ideas of the different ways we can articulate what well-being actually is. And frequently what they refer to is relational well-being. So relational well-being being interpersonal relationships, community, that these are very, very important to how we understand or how we experience well-being. That it's not individualized and atomized. There is a personal journey, but that's not sufficient on its own. So interpersonal would be quite important. Also time affluence, that we have more time, but also there are various other domains in terms of the well-being that are really important, that can allow us, if you can see in this figure here, to, I suppose, deplatform consumption as the main route to well-being, and actually consider other parts of well-being, which has a long philosophical history, and as I said, is occurring now in many contemporary theories from psychology, physical health and wellness, well-being research, well-being science, and various other fields, including the capability approach and needs that occur in kind of development and economic macro approaches. So in sum, I think we need new thinking, we need new framing, we need new analysis, we need new governance. I think some of these issues have kind of been pointed to by Celine, and also in a different way by Vincent in the last presentation, that there are limits in terms of how we have actually looked at a lot of these problems, and we need to actually really consider not just that a radical transformation means deep emissions reductions or deep changes to how we view growth or development. We also need to really think about how we frame the problems, how we analyze them, and how we introduce governance and institutional arrangements that can actually implement these and maximize our well-being. So in terms of new ways of thinking and framing energy consumption and technology and wider development, we need to consider not just the technological aspects, but the kind of wider aspects of consumption, which has a strong link to well-being. Although it resides in a different field, I would strongly argue that there's a need to integrate these in terms of our perspective. So that sits very firmly within the philosophy of sustainable development, that the integrated nature of dimensions, interdependency, interrelatedness are very, very important. Also that it needs to be futures oriented in terms of understanding transition and transformation, but also in terms of that journey that's acknowledged in, I suppose, the frontier of sustainable development and sustainability, which also comes through in sustainability sciences, which is a kind of a wider frame that seeks to be interdisciplinary and transdisciplinary in its approach. For this, we need to do exploratory scenarios. I would argue, not prediction. I think this has now a tradition in terms of how we understand transition and transformation, including the modeling of mitigation for the last 20 years, that we don't look at prediction, we look at alternative plausible developments. In terms of sustainable development paths, in terms of what might be desirable changes in backcasting. We can also bring in public participation, the demos, responding to the ethics of actually understanding development, because to solely reside our understanding of the future or our decisions and prioritizations of what's important within the modeling community has ethical challenges, and that transdisciplinary and public participation approaches are useful in this. We arguably need new approaches to governance through, again, the public participation in the visions, through the systems levers, through considering social structure and agency together rather than a single-pronged approach. To put lifestyles in a social systems context, to understand the agency and structure, to understand particularly synergies and win-wins in transformation, because the idea of sustainable well-being is essentially a double dividend, that you can improve well-being while reducing consumption, with the rider, and this caveat is very important, that this is not recommended for people in poverty, people on lower incomes, that the needs perspective is still valuable there, but to give a full flourishing perspective on well-being, it's arguable that we need to consider a conception of well-being that involves things like flourishing, and that can push us towards synergies and win-wins in transformation. So I hope I haven't run over time here. Thank you, everyone, and a special thanks to all of the organisers for continuing to proceed with this conference. I think it's a really great idea to continue rather than postpone. Thanks so much.
Thank you very much, Karik. I'll make sure to pass on the congrats to my colleagues. We are a team. It's not just me, it's many other people working behind the scenes, and you'll see more of them in the coming days. Thank you so much for this insightful presentation. I'm just going to pass on to the questions. And you have about 8 minutes to answer, so you have a little bit more freedom to do that.
Okay.
Well, the first question would be from Joel, who points out that you've been very conceptual, but how concretely do you formalize well-being in your model?
That's an interesting question. It is very conceptual in terms of one of the priorities of the research was actually to reconceptualize what could be considered well-being. In the model itself is a model of consumption, so it needs an intermediate relationship between well-being and consumption, and that can be articulated through a scenarios approach, which is predominantly actually a qualitative methodology to understand and articulate what a future vision of well-being could be, and then it will infer links between what the material footprint, what the consumption footprint of that is, which is I suppose, strong in a tradition of combining qualitative and quantitative scenarios, including the storyline and simulation approach of Alcamo. So it's not, well-being itself is not formalized, particularly in the quantitative model, but the scenarios methodology itself does formalize what is considered in a particular scenario a route to sustainable well-being, and what the well-being aspects are in terms of the relationship to consumption.
Then there's a question of Andres, whether we have enough energy resources to make the transformation. So it's on a biophysical constraint of transformation.
That's an interesting question, because I suppose in actually understanding transformation and transition, well, transition is often understood as something that's more managed. Transformation may be more radical, but it can also be more painful, more difficult, and that could come with energy implications in many different ways. And by the way, I'm not advocating for transformation en masse, because I think it's unethical to do that. I think we need to understand really clearly and be cautious. And although we need to move forward, we need to be cautious about just introducing a transformation which is potentially revolutionary and could have huge implications for human well-being in an ethical sense. In terms of the energy footprint of that, well, I would argue that this is conceptual research around trying to understand the similar to what Vincent articulated in the last presentation. Well, if we move on well-being pathways where we prioritize well-being right throughout the structures and systems of society, governance, and also in our individual lives, what might be the potential emission or plausible emissions reductions from that, and counter that against technology changes. I would regard reducing or moving to a well-being that's less defined by consumption as inherently including lower demand for energy services and lower demand for energy in general. So I would think that in general this actually entails it may be quite possibly a significant decline. I give you an example. One of the I suppose the key sectors where this has been looked at was acknowledged in the IPCC SR 1.5, where they looked at in terms of transport by reducing demand and moving to public transport, again, which Vincent also referred to, can potentially be up to an emissions reduction of 50%, against 50% on the decarbonisation by electric vehicles and biofuels. So I would regard energy, a reduction of energy being actually key to and intrinsic to this approach.
And maybe the last question in this presentation would be from Jerome, who asked, that he says you suggest beyond mitigation, but won't the lifestyle changes be the outcome of mitigation policies imposed by the state, such as carbon pricing, that incentivize people to adjust their low carbon lifestyles? Do you think other policies are more important?
I would argue yes. I think there are a lot of, and this would go back to some of the thinking by people like Felix Kreutzig, who Celine referred to earlier. I think there is a role for things like carbon taxes in terms of shifting lifestyles. I think a lot of the empirical evidence, rather than the theory from environmental economics, is really questioning what it can achieve in that it's more a complementary measure in terms of key sectors like transport, and that there is a need to really consider aligning well-being and sustainability approaches with regulation. And I think regulation has to be part of this picture. My feeling is a lot of the literature is pointing towards regulation and the structural approaches, the kind of contextual approaches that were referred to in the last segment as well, as being key, as being very, very important. And again, I wouldn't discount the need for things like potentially consumption taxes in addition to carbon taxes. But I think we need to look at, I suppose, a wide suite of policies and levers that we can actually achieve a transformation or the synergy of sustainable well-being.
Brilliant, Tariq. Thank you so much for your presentation.
Thank you.
Please do continue your interaction with our audience. We're quite a numerous bunch, more than 130 people I saw before. So please do go to Discord and continue the interaction there.
Okay.
And I'm going to move on to Sibylle Bruntrath from OECO Institute, who's going to talk about quantifying lifestyle changes. So she's going to present how much a change in electricity use, living space, and mobility can bring us towards the EU targets for 2050. Thank you, Sibylle, for being with us. The mic is yours.
Thank you. Thanks for the introduction. And also, I would like to take the opportunity to thank the organizing committee. So I think it's really totally impressive how you just managed to set this up as an online format. So thanks very much for that. So I will present our work on the quantification of the impact of lifestyle changes in modeling. So to some extent, this is similar to what Vincent presented, but in some ways, this is also completely the opposite because we are treating the district level, so really the local level, whereas Vincent showed us the model that covers like 29 countries. So here we go to the local level. Why are we doing this? So similar to what the previous speakers pointed out, here we can see the per capita emissions in Germany today, and then we can see the emissions that we need on a long term if we want to meet the 1.5 degree target. And even though, of course, there's uncertainty about what exactly those emissions could be, also one can have different views on what is a just distribution. It is completely clear that this is a really drastic change and that we really need to change many things for that. And let's say the very important question of how this can actually take place. Here I would like to show the citation, which I think Vincent also mentioned, of the high-level panel on the European Decarbonisation Pathways Initiative, where in the report they say that a scientific consensus exists stating that it is difficult to reach the targets of the Paris Agreement with technological and policy measures alone without addressing social changes too. And I guess with the audience here in the virtual room, this statement is totally unsurprising. So one could even argue that maybe difficult is not the right word. One could say it is even impossible without lifestyle changes. So maybe what is more remarkable about this statement is that it is finally really coming also in the policy discussion. Because what Vincent also pointed out, if we look at modeling studies right now, lifestyle changes are really hardly covered. So here in this table, you can see a selection of modeling studies that is taken from an article of my colleagues, where they looked into scenarios, in that case for Germany, and sort of analyzed to what extent they are covering lifestyle aspects. And what you can see that really only very few scenarios are covering them at all, and also only partially. So it's really something that is not covered very much. And if we assume that lifestyle changes are needed for decarbonization, then it's of course very important to also cover them in the modeling studies. I mean, here I'm speaking about modeling studies that are really used for policy making, where different pathways are explored and where it is explored what is actually needed to reach the decarbonization targets. So it's important to have lifestyle aspects here to now to quantify them and to get more insights for policy making. So what I present today is first an introduction to the modeling framework. As I said, we are covering the district level. Then I will speak briefly about the scenarios we've been looking at. And then I will show sort of the results of the comparison of the CO2 reduction potentials, both in the use phase and in the construction phase. And then I will draw some conclusions. So regarding the modeling framework, here you can see a screenshot of the model. And I have to apologize that this is in German. So the model was developed in a German project that was done together with a municipality. And this model was really developed to help urban planning processes and also the communication about these processes. So the model is in German. In any case, I will show you. I hope this works now. I will try to share the screen. I hope this doesn't mess up everything. Let me see. One moment. Okay, so now you should be able to see my screen. And then I can briefly show you. So this is just a picture, a view of the model. If it's very small and you cannot read it, don't worry, because it's in German anyways. But what you can see is that the model reacts directly to user input. So like just to show you an example, you can see here on the right side, the CO2 emissions in the use phase and in the construction phase. And if I change now the level of photovoltaics that we have, for example, then you can see directly how the emission levels move. So there are many different levers, many different aspects where you can make changes as a user, and then you can immediately see the results. So in that sense, the model is really user-friendly and fast, which is important if it is used for those urban planning processes, for the communication, so that one can directly show what impact different aspects have. So I will now go back to the presentation. Could you put the presentation back on?
Yeah, just a sec.
Okay. Yeah, I hope I didn't mess up everything. Okay, thanks. So we are back to the presentation now. Okay, so this just to the modeling framework. And the lifestyle dimensions that are covered in this model or in the tool are, on the one hand, the per capita floor space. And there are two different aspects to this. So one thing is the housing structure. So as I said, we are looking at districts. So there are, of course, districts that look really different in terms of building structure, housing structure. So in a district with lots of single family houses, on the one hand, the floor space tends to be larger, but also on the other hand, the energy consumption per square meter is higher due to the larger surface area that is exposed to cold temperatures. So this is one aspect, sort of really this completely different housing structure. But then also another aspect is varying the floor space within a given building type. So knowing that one will have a district with multifamily houses, really just saying, okay, I use 10% less floor space per person. So these are the two aspects. Today we will only speak about the second aspect. Then the next point is mobility. So here there are two aspects. One are minimum parking requirements. So in Germany and probably in many other countries, when constructing new buildings, there's an obligation to set a certain amount of parking spaces per apartment, basically with the aim of not having the cars on public streets. And this, of course, is in contrast with trying to get mobility or individual mobility down. And so this is one aspect. One can sort of, in the model, one can look at how different minimum parking requirements have an influence. And then the other one is the mobility behavior. What we are doing there is we base the values on the previous study and on average behavior, and basically it's a different modal split, so different use of public transports, bikes, walking, and individual mobility using cars. Then the next aspect is electricity consumption. So here the values are based on a German study where sort of the electricity consumption of households is classified in something like the energy classes that, you know, from the energy label. So these green to red ones consuming little and consuming a lot of electricity. And here, so we vary the electricity consumption. So this is actually a bit mixed between technological and lifestyle aspects. And then what is also covered is residential waste, but we will not speak about this today. So now regarding the district that I'm covering today, it's a district called Ludwigshöhe-Viertel, which is located in Darmstadt in Germany. And what is important here that is it's a conversion of a former military site. So it is a new district that is constructed from zero. And it's planned for a little more than 3,000 people. So all of the results that I'm showing today are for this new build district. This is important because this makes big difference. Then the four scenarios that we are comparing are, on the one hand, a reference scenario. So in the reference scenario, all the buildings are constructed according to the national building codes, and lifestyle changes are not included. So basically it's the average behavior options. Then we have a lifestyle scenario where there's a focus on lifestyle changes, so in terms of floor space and mobility behavior and electricity consumption, whereas the technological aspects are just as in the reference scenario. Then we have a technology scenario where the focus is on technologies, on energy efficiency and renewable energy technologies, basically. And then we have the integrated scenario where both of these two options are combined. So what exactly are we looking at? What we can see here are the per capita CO2 emissions of Germany. So the whole thing are the emissions of the average per capita emissions in Germany. And you can see here the various aspects: food, public emissions, so basically just emissions from public services distributed over the population, then emissions from consumption, and then mobility is separated into long distance, so holiday flights and so on, and short distance, and electricity and heat supply. And what we are covering here are only those last three aspects. So it's heat supply, electricity, and mobility. The reason for that being that these are the aspects that can be addressed directly by designing the district. So it's sort of, as the focus is really on the planning process in the district, we cover those three aspects. Now, what is also important to note, what we show here are the average emissions in those three aspects. So this is basically here, the left bar is basically exactly the same as what was in the red box in the previous slide. So we see the per capita emissions for those three aspects. And then in the right bar, we see the right column, we see our reference scenario from the modeling here. And what is maybe at first sight surprising is that even in the reference scenario, the emissions are much lower than average emissions. But this is due to the fact that we are looking here at the new construction district. So by default, the buildings, even though they, let's say, just follow the national building code, they're of course much more efficient than the German building stock on average. And for mobility, the main reason is that it's an urban environment, and so mobility is sort of lower. The mobility requirements are lower than the average. Okay. Now we come to the comparison between the different scenarios. So what we can see here are the emissions in 2020. So this is not a projection yet. So this is just sort of constructing the district in different ways, the immediate effects. What we can see here, the first column is the reference scenario. So here we can see the emissions in the reference scenario, exactly the same what we saw on the slide before. And then we compare this on the one hand to the lifestyle scenario, to the technology scenario, and then to the integrated scenario. What we can see is that in the lifestyle scenario, we get an emission reduction by 21%. In the technology scenario, this is a bit larger, it's 26%. And then what is also important that in the combined version, in the integrated version, we get minus 42%. So, I mean, of course, this doesn't add up because, let's say, if I have lots of technological process, then lifestyle changes become less important, or the other way around. But still, the combination brings the emission down considerably. Now, looking at the longer term effects, we can see here the projections until 2050. So for each of the scenarios, for reference, lifestyle, technologies, and integrated scenario, we can see the 2020, 2030, and 2050 value. And here it is even more pronounced, the difference that we reach with the technology scenario and the lifestyle scenario in 2050. The reason for that is that until 2050, we assume also that outside the district, that sort of there's a transition of the electricity system, for example, outside the district. And so the technologies become more important in that sense, or lifestyle, there's less opportunities for lifestyle changes. Okay, then what is also interesting is to look at the construction phase. So as I said, this is a new build district, so it has immediate consequences on construction, on the CO2 emissions in the construction phase as well. What we can see here are the construction phase emissions for road construction, mobility, which are mainly the parking spaces and the buildings, and comparing the reference scenario to the technology scenario, we can see that we basically have no changes, because constructing buildings that are more efficient even the embedded emission may be higher. So an important point here is that in the lifestyle scenario, we also save emissions in the construction phase, which we don't save in the technology scenario. So from, let's say, building less parking spots, and also for the floor space. Now, combining the use phase and the construction phase, we can see the first thing that we can see here is that in the reference, looking at, for example, at the reference scenario, we can see that the construction phase plays a much smaller role as compared to the use phase. At the same time, when looking, for example, at the integrated scenario, this, of course, is reduced. So this difference is reduced once we have less emissions in the use phase. Once buildings get more efficient, of course, this construction phase becomes more important. And another important point here is that if we look now at the total reduction potential, we can see that the lifestyle now has 24%, whereas technologies has 20%. So here, the lifestyle scenario has even a stronger reduction potential. With that, coming to the conclusions, so the first thing that we could see here in this work is that lifestyle changes have similar impact on CO2 emissions as compared to the technological options. The other point that I wanted to make are the lifestyle changes, that lifestyle changes also reduce CO2 emissions in the construction phase. And I mean, what is really, I think, a very important aspect is that the study of lifestyle changes need further investigation. It's important to quantify those in modeling studies at all levels. So here, this is the district level where it can go directly into planning processes, but at all levels, I think it's very important. So I'm also happy to see this in Vincent's presentation for the EU. I think it's really important to get more information on that. Then at the local level, the integration of those aspects in the planning processes provides significant saving potential. So it's really important to think about this when constructing or changing districts. And one last point is that also this municipal district level can have an important role in developing and testing policies that address lifestyle changes. With that, I would like to finish and thank you all.
Thank you very much, Sibyl. We can skip immediately to the question. You're quite on time, so we have about 8 minutes to answer all the pending questions. Let's see. First, we have Jaco, who says, who wanted a clarification. Well, I don't know. I don't understand this question. Maybe I'm just gonna. Anders asks if it's possible or even desirable to rethink the way we build cities. Is it desirable to still have these mega cities projects, or should we move to a more sparse urbanization plans?
Okay, so I mean, this is a very broad question that, at least with the model, cannot be answered. So here, this is about individual districts, and regarding megacities, of course, there are so many aspects. So I mean, from the building energy consumption perspective, probably it's the right way to go, but then there are all those different aspects. So this is a question that cannot be answered with our approach here.
Maybe one personal question from my side. The scenarios that you showed show a substantial reduce in emissions, but like in the best case, it was about 50%. So in a long-term perspective till 2050, when we're talking about emission neutrality, it still seems like really, really too much. How do you think we could like get those emissions down? Or do you think like we actually have to rely on negative emissions to compensate for the buildings sector?
Yes, so that's a good question. I mean, you said that the emissions go down by 50%, but also it's important to see from where we started. So I showed on one of the slides the difference to the German average. So we already start at a district that it's a new build district, so where the emissions are much lower than the usual or the typical levels. And this is the 2020 perspective. So if we go to the 2050 perspective, where sort of the electricity mix is also different, because the 2020 perspective assumes that the electricity that goes into the district is the current electricity mix of Germany, where there's a lot of coal in the system still. So one has to take the 2050 perspective and also take into account that this level that we start from is already quite good in a sense.
Then, thank you. And then Mikhail points out that the comparisons between lifestyle and technology scenarios weigh heavily on what is included in the embedded assumptions and what changes are deemed feasible.
Yes.
How do we know what changes are feasible?
Yes, I mean, yeah. So this was a bit of a challenge when choosing the scenarios, because as I showed the model, you can just sort of play around with the different parameters and see what happens. And so really choosing those scenarios was a bit of a challenge, because you have to focus on given values. And so in a sense, this is also a bit in contrast to what the model was built for this sort of trying out different options. And of course, it depends. But the lifestyle changes that we chose were really, I mean, it's 10% variation of floor space. One can say it's a lot, but still, I mean, the variation between different countries and different areas, even within a country, are much larger. So we try to choose changes which are realistic in a sense.
Then another interesting question from Thorsten, I think, is whether you included into the lifestyle changes also co-housing or different living concepts that he claims would radically reduce floor space per person. And maybe if I can extend this question a little bit, like here in Spain, there's this tendency that a lot of people have summer residences. It must be also the case in Germany. So should we also push the lifestyle changes towards that, like maybe people don't need two different homes, and whether they can just have a more convivial living with more people within a smaller floor space?
Yes, so I mean, in this work, we don't make any particular assumption on how the floor space is reduced, so how people organize in order to reduce the floor space, and the question on holiday houses. So this is, of course, it depends, of course, also from a heating perspective. It depends if the holiday house is heated or not. But I mean, from the resource perspective, it's clearly better not to have holiday homes. But these concepts on how to reduce floor space, and I guess this is also why this is so difficult in policy making. It's really telling people how to live, what to do. This is a difficult question, and here we didn't go into the question how this is actually achieved. But as I said, we took a 10% change, which is not so much.
And maybe the last question from Inigo, who's actually the last presenter in this session. What's the comparison between rehabilitating, renewing the old buildings versus building new sustainable buildings from scratch? What's your take on that?
Yeah, so I mean, we have also applied the model to existing districts and to renovation of existing districts. And I mean, the question if a building should be renovated or it should be replaced by a new building, of course, depends very much on building itself. But in general, of course, it's a big difference what you can do with existing buildings. So in terms of floor space, for example, it's of course much more difficult to make changes in existing buildings. So in new buildings, what was mentioned in the previous question, there are concepts on how to design the buildings in such a way that the floor space can be adjusted to the number of people and so on. And this is much more difficult in existing buildings. So yes, one has much more possibilities, of course.
Thank you very much, Sibylla, for clarifying all those questions. I again invite, if there's any pending questions, to move it to Discord after the end of this session. Now I'm going to ask Inigo from University of Valladolid to wrap up with this session. And Inigo's going to talk about scenario modeling of global transport, decarbonized technological and lifestyle changes. So what's the particular take on how radically transforming our way we move around places could also contribute to lower carbon footprint? Hi, Inigo.
Hi, thank you very much. Good morning, everybody, or good afternoon, depending where are you now. Do you see my screen with my slide, first slide?
Yes, we see it.
Okay, thank you very much. Okay, so I would also like to thank you all the organization. It's very interesting and amazing the work you have done to organize this. And also I would like to specifically organize the people who build this session, because the 4 presentations are pretty much aligned. And we all know that in conferences, this is not always the case. So the good thing is that most of my introduction and motivation has already been justified and said. So I'm going to go faster in that part and maybe commenting on some things which have been said by my colleagues before. So my work, the work I'm presenting here is a collaborative work with 3 colleagues from the research group. About modeling, how we could model a global transport decarbonization. So now we are jumping to the global level from European and district. We are going to the global level. So of course we do not have so much detail, but we are able, because we have global perspective, to tackle things such as biophysical constraints. So this is, I think, an interesting dimension, because with integrated assessments from the IPCC, which have been already discussed in this session, and most of it, I mean, I agree with what have been said. They simulate technology scenarios, but we may ask if they are feasible. Not even if they reach the target or not, but if they are inherently consistent and if they are feasible, just because an availability of energy and an availability of minerals, etc. So with the model we use, we are able to check these kind of things. Okay, so well, as I said, these things have been already said, so I will go fast. The global transport system is very unsustainable. It's only, let's say, 14% of emissions, but it is increasing this share. And it's also very important to know that there is a very a huge regional heterogeneity in terms of this. So here in the second panel, you can see that these countries of higher income, the emissions of transport represent over 20%, while in other the rest of the regions of the world, this share is much lower. No, so this problem of global transport is largely a problem of let's say, call it rich countries, and of course, if development countries in development, as they are so many times called, want to follow our path, it is likely that they will arrive to similar shares. And also on the left-hand side of the picture, you can see the increasing contribution of international trade transport. No, also linked with what the previous colleague had said. Okay, if we go a bit more in detail, we can see that of this transport, most of it is road transport. Okay, so this is the blue shade in these histograms. And then if we go even further, if we go to the modal share, we can see that in road, which dominates, for example, let's call them in developed countries, most of it is light-duty vehicles, so private vehicles, and then there is a minority of buses. But if we go to other regions, we can see that this is a bit, very different, no? And light-duty vehicles are not a majority in most cases, and there are high shares of buses, etc. Okay. One more thing is that, of course, even in the same category, there are different variations in countries depending on different aspects, such as social, cultural, urban, mobility planning, the availability of infrastructures, etc. No? So here we can see that, for example, taking as reference just the GDP per capita, for the same level of GDP, there is a very huge range of vehicle or ownership in different countries. No, so, and finally, we are all aware that in terms of passenger per kilometer traveled, the different modes of transport are very different. No, this is not news for anybody. The thing is that the use of a model allows to take all these heterogeneities in a consistent way together. Okay. Up to now, I have focused just on emissions, but of course, we have to be aware that the model of the private internal combustion vehicle has many other drawbacks, as for example, public space occupation, traffic jams, accidents, the segregation of spaces, the requirement of large highways, etc. And of course, for example, in this last case, the requirement of large highways, which are very, very expensive and which fragmentate the habitat, has consequences in other sustainability dimensions. Okay. And here the worrying issue is that transportation demand is usually expected to continue increasing in the future. Okay, so as my colleagues have said previously, and I'm not going to insist on this, most modeling works have focused before on technological change. Technological change means efficiency, replacing by electric vehicles, eco-driving, etc. While lifestyle change are acknowledged always in theory in the introduction, but then usually not modeled. And when they are done, they are usually very soft measures, okay? And on the other hand, we have a rich literature, theoretical, let's call it, which is pointing to the fact that these lifestyle change measures, specifically in the transportation sector, can have very substantial benefits. And also we have the paradox that all the models, current models, which are projecting technological changes, they are not able to reach the targets, even, if they don't use speculative technologies such as BECS, which was also said before. Okay, so in this precise study, this was our objective, to test in combination with technological changes, which radical lifestyle change in the transportation sector will be able to achieve global reductions, global greenhouse gas reductions, substantial greenhouse gas reductions. So in this study, we took a target of a 60% decrease from current levels. Okay, the tool we are using is a model, is an integrated assessment model called Medea's World, which we have been developing for the last 4 years and which is still under development, which I'm not going to enter into the detail of the model because, of course, it's quite complex for the time we have. But the only thing I wanted here to point out is that we have all the dimensions. We have a demand, who goes to an economy module, so goods and services are produced, and then we have on the other side of the model all the biophysical supply, let's call it. We have energy, we have minerals, etc. The consumption of resources means emissions of CO2, which translate into temperature increases, which through damage functions affect feedback the behavior or the economy back. Okay, so here you can see many arrows. There are many feedbacks, but I just point these two, which are absent in many models, such as climate change damages and the availability of minerals, for example. Okay, so a little description on how this is modeled in the Medea's model for going to scenarios and results. In Medea's model, we have an economic structure which is composed of 35 economic sectors with input-output. And here we take the WIOT database as reference. So this means that we have inland transport, we have air transport and water transport for the production, and then we have the transport for households. Okay, so we have a nice disaggregation in this side, but we also have a nice disaggregation in the technological side, where we distinguish between 4-wheels vehicles, 2 wheels, electric bikes, heavy vehicles, this means mainly trucks, buses, train, as well as non-motorized, which is mainly bike, non-electric, and walking. And of course, these vehicles can be fueled by these 4 final energies, liquids, like gasoline or diesel, gas, electric, or hybrid combinations. Okay, so we have a demand which is covered with a set of technologies, and then we get the energy consumption, we get the mineral requirements of here we focus mainly on the mineral requirements of electric batteries of the electric vehicles, and then we have the greenhouse gas emissions. Okay, for the batteries, in this version of the model, we just have one what we call representative technology. That means that all the electric vehicles install LMO batteries. No, this means lithium, manganese, oxygen, and which have this amount of metals. No, each battery is around 200 kilos in a small car. In the Tesla big car is closer to 500 kilos. So this is all here occupying the lower part of the vehicle. So you have in each battery 40 kilos of aluminum, 23 kilos of copper, 3 kilos of lithium, and 130 kilos of manganese. As I said, there are more types of batteries, but as a first approach, we decided to work with this one, which is a representative technology. Okay. So this is the framework, and now I'm going to explain a bit the 4 scenarios which we are testing in this work. We are testing basically a business as usual scenario, which we call expected EV trends, EV from electric vehicle. Then what we do on top of this scenario, we put much more penetration of electric vehicles, and we name it EV high. Then on top of this, we put a lot of electric bikes instead of so many electric vehicles, and we also put a share of light electric vehicles, so mainly electric bikes. And then finally, so these 2 scenarios are, let's call them technological scenarios, and the last one, on top of these technological options, incorporates lifestyle changes. No, when we have named it at the growth scenario, because in fact is what we are doing, because we are implementing these lifestyle changes at two levels. So at the level of consumption, so let's say in the bottom part, we are imposing a reduction in the demand of transport from households. So there are big reductions of 60% in inland and water transport and an 85% of reduction in air transport. Okay, but on the side of the production, let's say in the economic structure and so on, we impose that the GDP per capita is not anymore, I mean, the goal of the system is not to continue fulfilling GDP per capita increases, but we put a target and stabilize around 25% below current levels. No, this is more or less aligned with what the degrowth proposal is saying, and this makes that the production side is also reducing the demand for transport. So a kind of relocalization of the economy. Okay, so and then just some information related to the recycling rates of minerals, because as I said, we are going to look to the biophysical feasibility of each scenario. In the expected EV trends, because it's a business as usual, we just assume that the current recycling rates are maintained into the future. And in the other three scenarios, we assume a very high increase. For example, lithium currently is not recycled, or recycled in a very negligible part, so it will be from 0 to 25%, and manganese today is recycled from 50, and we assume until 80%. Okay. Okay, so once the methods and the scenarios are defined, we can go to the results. So first results, each line is one scenario, and here is for greenhouse gas emissions of the global transportation sector. No, so the yellow one is the reference scenario. The green one is the one with high electric vehicles. The blue is the one when we put a lot of electric vehicles. And then the red one is the one that we have called degrowth. Okay. So here you can see that the only scenario reaching the target is the one we term degrowth. Okay. This is not a coincidence. I want to be transparent with you. Some of the parameters of the scenario have been set to reach this objective, because this model is not a policy optimization model, so it's a policy simulation. So our idea was to simulate these three scenarios, and because we saw that the target was not achieved, we developed backwards a scenario, a propositive scenario reaching the target. Okay, so this is not a coincidence. This is in terms of world GDP per capita. This is also, I think, quite interesting and different to other models. No, here in gray dotted line is the planned GDP per capita in growth-oriented scenarios. No, so I don't remember now exactly, but it was probably 2% growth per year, something like that. So what we see is that here in these three scenarios, which are growth-oriented, the GDP per capita is not able to follow the planned path. And we can see that more or less they are stable with a very low increase. So this, in terms of a paradigm where growth is needed, an economic system where growth needs to grow, the economic size needs to grow, these are scenarios of crisis or recession. Okay, so we will say that they are hardly feasible or even unfeasible. And the growth scenario, as I said, targets asymptotically a lower level of GDP per capita, and if it doesn't grow the GDP per capita, this is not a priori a problem. Okay, in terms of minerals, here we can see a table with the share of reserves which are spent in each of the scenarios by 2050. No, so reserves, mineral reserves. Let me recall you that they refer to the part of the mineral which is below the ground, and which, given current technology and current knowledge, it could be extracted easily. Not easily, it could be extracted economically profitable, etc. Okay, So this is a kind of indicator which has certainty that these minerals really exist. Okay, so here I have marked in bold those numbers which surpass the total reserves. Here, of course, we are talking about cumulated extraction from the mines minus the recycled amounts. And we can see, for example, that in the EV high scenario where we put a lot of electric cars, we get problems with lithium. We get problems with manganese. In fact, we get problems with manganese in the three first scenarios, and even in the degrowth scenario, where the number of vehicles decreases a lot, we are in 2050 quite close to this to the current amount of reserves. Okay, just to start with the conclusions, our study is just a corroboration that technology changes are not enough to achieve a global sustainable transport system, that lifestyle changes are unavoidable. So here, as Sibyl said, this is not news for the audience, probably. We also highlight the risk of mineral availability in terms of manganese and lithium. And precisely when I was preparing the presentation, this news happened, that the European Union put lithium also in the list of critical raw materials. So this is coming also in the policy arena. So the numbers that we see, that of course this is order of magnitude results that will be compatible with this large decrease of greenhouse gas emissions in transport, will need a 60-85% in the reduction for inland water and air transport. Here for air transport, I would like to make a comment because, for example, I don't have now in mind data for the European Union, but I have data for UK, which says that 70% of the trips by airplane are done by 10 or 15% of the population. So we have here a huge issue of inequality. So a 85% decrease in the demand for air transport is not going to affect the majority of the society at all. So it doesn't seem so radical as the number shows. Okay, this for the results we obtain. The Medeas model, which we are using here in this study, is in fact being developed in a specific H2020 project, which is called Locomotion. You can have there the link you want to access, and the objective of this project is to enhance the Medeas model. So I would like to finish the presentation telling you some things that we would like to improve. We are planning to improve in the project, and maybe also if you have any other ideas that we can incorporate, since now we are, let's say, in the beginning part or the initial part of the project. So some of the things that are very important is the modal change to public transport, to model the possibility to share vehicles, to be able to put taxes on fuels usage. Also, as I said, with the distribution issue, the possibility to disaggregate at regional and household income level. And then also from the point of sight of minerals, it will be very interesting to consider a portfolio of batteries which depend on different minerals. So when one mineral is scarce, the model can switch to others if necessary. So this is all for me from my side. Thank you very much, and I'm looking forward to your questions.
Thank you very much, Inigo. Okay, we have about 5 minutes to address the questions, which there's quite some. So Franci, for example, asked, what are the social and environmental indicators that you use?
What? The question is, which are the social environmental indicators? Okay.
Yes.
Yeah, I haven't shown the results on this just to shorten the presentation, but you have to think that because this is mainly a biophysical and monetary model, we needed to translate this into something closer to society. So the kind of indicators we have are per capita indicators, per capita GDP, per capita renewable use, per capita electricity, these kind of things. Okay. We do not have, for example, employment, but this is going to be included in the model, which is very important. We will also have inequality when we have a household income category. So this is this is being improved currently.
And then a question, my personal question would be, why do you do your model based on GDP reductions? Why don't you use more biophysical indicators like energy? Because like if you assume high energy efficiency improvements, you don't really need to decrease GDP. It actually doesn't say anything about the well-being necessarily, but why don't you build it around energy, and why did you? Yeah.
Well, this is in fact a limitation of the current model, which also we are going to address, because the model was developed for providing policy advice, and in policy advice it was required that the model follows. So the driver of the model was the GDP per capita. So now, because we don't like this approach because it has many limitations, we are evolving towards that the demand functions do not depend on GDP expectations, but on specific well-being indicators or so on. So we are going on that path.
Okay. And then Jaco asks if you're thinking about incorporating the concept of carbon budget, because you haven't talked about the temperature impacts of, for example, the degrowth model.
Yeah. Yes, I didn't show these results. In this study, in this precise study, I think we deactivated the climate change impacts because it adds much complexity, and then we cannot easily distinguish the effects of each scenario and the climate change impact. So for this presentation, I decided to keep it simple.
Right. And then finally, maybe the last question from Melissa. She asks, is your assumption constrained in terms of recycling of rare resources just to 80%? Isn't it possible to go further than that? And also, if you thought about like social justice limits on extractions.
Well, I will start by the last one. I imagine she's thinking about, for example, that some resources are extracted in one place and consumed in other place. If this is the case, because the model is global, this model, it doesn't see regions. So we could not capture this effect. And about 50% and 80%, yes, we could have set a higher level, but we also have to be aware that because of thermodynamical limits, a recycling rate of 100% is physically impossible. So how close we can get to 100%, maybe 90%, but it depends a lot on the design of the product. Okay, and this is maybe going outside of transport, but computers, mobile phones, etc., all the devices which have batteries, these devices are not designed for being recycled. These devices are designed to have the highest technical performance. So the battery, the lifetime of the battery is the longest, these kind of things. And then this makes that when you want to recycle, the elements inside are very, very, how to say, difficult to separate and very expensive. And that's the reason that currently it's not being done. So the thing of recycling, of course, it's an issue of preparing the infrastructure. So when the batteries reach their lifetime, they are recycled, but it's also a process which have to be work upstream, no, in the design process.
Maybe just one more question because we have 2 more minutes available. Also from Francie, she refers to when you said that only 15% of the population regularly flies, uses those services. So it's a bit of a privileged good. Don't you think that implementing like policies like carbon pricing, for example, may then only lead to a decrease in demand among those who already use those services very occasionally and not those who can afford it anyway? So isn't there a certain limit to those policies?
Yes, well, in the points I wrote about further development, it's true that the only policy I put was that one, but I think we should talk about caps. Caps to be sure that certain limits are not surpassed. As you said, if people can pay, they will, most of them will continue doing it. I agree.
Brilliant. Thank you so much, Inigo, for your presentation. And once more, thanks to everyone on behalf of the organization team who participated in this really interesting session. I would encourage you guys to continue your discussion, to ask any questions you have to the presenters in the Discord chat that works like a forum. So please go there and continue working. And with this, we conclude this session. I hope you guys to see you guys in the following session, which is going to take place after a lunch break. So this is going to be at 3 p.m. Roadmaps and visions. Nice having you, and see you soon.
Bye bye, everybody. Have a nice conference.
Adios.
Adios.